Hey everyone. So in this video we're going to look at loading a data set and computing some descriptive statistics and visualizing a data set in an introductory way. A lot of this type of information would be quite commonly found at the beginning of a results section, for example, in a journal article, where you might provide a table of descriptive statistics or summary statistics, or you might present a visualization of the distribution of a set of data. And that's what this video is going to show. And we're going to work with the iris data set. So just to show you, the iris data set is in the system library package called datasets. But I want to bring it, first of all, to my environment. And I can do that I'll call it iris. So iris, I'm about to put in the line of code to call it iris. But in our datasets, you can see that the iris dataset is here, and its usage is simply by typing iris, and we can see some of it. We can see kind of a variable description. Iris is a data frame with 150 cases or rows and 5 variables or columns, and it gives us the name of each of those. Iris 3 is the same data arranged as a three-dimensional array of size 50 by 4 by 3, represented by S+, and you can read more about it, and you can see references. And here you can just see more about it, but to simply bring it into, these are examples on how to use it, and to simply load it, because the package is loaded. You have to remember that. So the package is loaded is just to call it iris, and you can see as I start typing it shows what it could be and gives a bit more information about it. If I run that line of code, it has now moved into my environment. You can see the code is run in the console. I can save this, so I'm going to keep saving my script file over time, build up my code, and here it is. And if I open it by clicking on it, you can see it opens and shows the data frame. If this had been, it looks very similar to Microsoft Excel. You can see each column, which is a variable, and it's the iris species, or the iris flower, has these 3 species within this data set. The Setosa species, if you scroll down, there's 50 cases of each of them. The versicolor species, and if you scroll down more, the Virginica species. And there's 4 measurements. So the data set has measurements of the sepal and the petal of these different flowers. So each one of these, so here's a case. It happened to be a Setosa species of the iris flower, and you can see its petal width is 0.2, its petal length is 1.4, its sepal width 3.5, and its sepal length 5.1. So that's our data set. Now what I want to do is, because I could have so many different data sets here, I need to tell OR what's the actual data set that I'm going to work with. And to do that, we use the attach function. And first of all, I suppose it's important to note, as you start typing it, it'll tell you the package that it's coming from, which is the base OR package, and you can see down the bottom right, it's the first one in the package list under the systems library. It's already installed. So I'm going to click attach, and I want to attach this iris data set from my environment. So I will select that and run it. Nothing, see, it's run, nothing has really happened in my in my console, because all I'm doing is saying this is what I want to work with now for a while. So if I want to get a brief summary or a brief overview of the data, and we can tell by opening it, it has 150 observations of 5 variables. We know it has 3 species, 50 of each type of species, and these different lengths. So if I go to summary, if I use the summary function in base OR, and I want to summarize my iris data set, and it will appear in my console, and I can save that to my environment, and I can call it whatever I want. I'll call it summary iris. Actually, I'll call it iris summary. I think that would be nicer. Iris summary, and it is this particular line of code that gave me that summary. So I'll paste that in here. The X comes up. It thought there was an unexpected end. It resolved itself. I'll run that, and here it is. You can see it's a table, and it's there if I ever need to. So later on, if I ever needed to again, I can now just use the code of iris summary, and that will bring up my table for me. So it's a quick way of calling back to it if I ever needed. If I was working with a different data set for a while, iris summary will always return this. And what does it give me? When we can see the 5 variables, if I maybe if I make this a bit wider before running it, yeah. So I make it just a bit wider just to show you, but you can see each of the 5 variables. So the sepal length variable, the minimum value was 4.3, the maximum value was 7.9. We have a first quartile, so the between the minimum and the lower 25% of data ranges between 4.3 and 5.1. Then the median, which is the middle data point, or the 50% mark, is 5.8. Its mean, or its average, its third quartile, so the cutoff point for 75% of the data, and then the maximum is 7.9. And you get that for all of those variables. But of course, the species data, or the species variable, isn't numeric. It's a factor, and it's just telling us there are 50 of each. And that is kind of useful to a degree, but the issue that we kind of have here is that, well, the sepal length, that minimum, we don't know, the differences. We've got these 3 different species, and we might want to know the differences between those species, as opposed to the overall minimum. We want maybe what's the minimum for Setosa, the minimum for versicolor, minimum for virginica, maximum, and so on. So usually, and I guess this is at least standard practice for me, is I put all the packages. I want to use the psych package, which is a package that I've actually installed myself. So it's here. I could tick the box and just open it up that way, or load it so I could use it that way. But I am going to instead use the library function and load that psych package. If I run this, it happens here. You'll see the tick has appeared, and I tend to put all of those at the top of my script file. And it's a good, I suppose, time now to note that the hash symbol indicates a note. So load required packages, and the first one is going to be psych, and then I'll say load data set, so I know that the next line of code was that. And now I will do compute descriptive statistics. Compute descriptive statistics, and all of this code here is going to be for that. The psych package is loaded, and I'm going to use the describe by function within the psych package, and I want to describe the iris dataset, but by a particular group, and the group that I want to use is the species variable, and OR is case sensitive, and if I run this, I'll make it wider, sorry, just before running it again, so it's more clear. I'll just clear my console as well before doing that. Now what we have is it's describing the iris dataset by group. So its group is Setosa, versicolor, and virginica, the three species in that species variable. And now we get to see variable numbers 1 to 5, sepal length, width, petal length and width, and species per group. And the n per group is 50, so it's 50 of those. We get our mean value, standard deviation value for those measurements within species. It's median. It's trimmed mean. So trimmed mean is it takes a portion of the data and it trims it from either side. Median absolute deviation value, which is it's a similar measure to standard deviation, but it's the median of the absolute deviations between each data point and its median. You have minimum, you have maximum, range. So the range is the maximum subtracting the minimum. Measure of skewness and kurtosis, and the standard error for each one, and that can be particularly useful to have. And I might want to call it as iris descriptives, so I can always call back to that instead. So iris descriptives, if I run that, you'll see now it's moved to my environment. I can open it. Doesn't give me a huge amount of insight here. You can see mean and stuff, but the easier way to view that is, and I'm just going to remove my console, or to clear my console, is to run the line of code of iris descriptives, and we bring up that table, and now that's stored for us forever. And it can be useful, of course, to save your environment. So now we'll have those forever. There are a few other options that we have in terms of computing some descriptive statistics. We can use we can use some very specific things. For example, there's minimum, and I appreciate that the minimum value is already able to be found, but if I do minimum iris and specifically, so we know that there are these different variables. So the minimum of the sepal length, and the $sign shows data set, $sign then gives you the variable. If I run this line of code, the minimum in the sepal length was 4.3. I could have done maximum within the iris data set, the petal length variable. We have mean, and I'll use the same one just so I can copy and paste. So of sepal length, we can get its mean, we can get its median, and so on. So we can find these out. We can find descriptive statistics out at an individual level, but the descriptives function in that psych package or the describe by function in that psych packages is particularly useful. One thing that you will have noticed, perhaps from each of those, is, so iris summary, if I just if I run that again just to show you. You can see first quartile, median, mean, third quartile, and max, and the iris descriptives. The iris descriptives also kind of give median, minimum, maximum. It can be useful to get different quartiles. Sometimes people want different quantiles. Sometimes people want to know quartiles, which are the default up here. You might want to know quintiles for whatever reason. So the cutoff points for the minimum, the 20% of the data, 40% of the data, and so on. And to do that, we can use the quantile. The quantile function, and if I just show you how that works, I just prefer to click on the run option. Quantile will automatically do quartiles for you, but you might not want it to be in quartiles. You might want to have any other distribution rather than 25, so 0 to 25% of the data, and it gives you those cutoff values. So you might want to be capturing the data for sepal length, but rather than quartiles, I'll just put a note here that these are quartiles. You might want to get the data for quintiles, for example. And we use the probs argument for probabilities, and it'll be in a sequence of, so we want to go from minimum to maximum. So I'm going to use 0 to 1, and now we implement the quantiles we want. So here we want quintiles, which is every 20%. So 1 divided by 5, and I'll separate these out just so I suppose it's easier to read. And this will hopefully, if I've done it correctly, give us quintiles. You can see my note has appeared there as well, and you can adjust this however way you want. So maybe you want it in every 10% of your data instead. And it'll give you the cutoff point. So this is your minimum value. If you took the bottom 10%, it ranges between 4.3 and 4.8. The bottom 20% ranges between 4.3 and 5 of sepal length. But of course, again, this is data coming from all of the different species, and that might not be what we want. Instead, we might just want to know these values, these quartile values for one of the different species, and indeed this can actually be very helpful. So perhaps we just want the Setosa data alone. We want to only have a data set which has 50 observations instead of the full iris data set. So to do that, we're going to take the iris data set that we have, and we want to only select the Setosa Setosa data, and we do that by using square brackets, and square brackets in R are parameters for a list or a vector or a data set. So things that go within this, it's us creating that type of data set. So we'll use the which argument, so which is, and then the iris data set, but we're actually not talking about the data set here, we're talking about the variable. So which is the species variable, which equals, and it's 2 equals here, and it's which equals Setosa, and nothing else. So what we wrote here is we want to create Setosa data, a data set called Setosa data, taking the iris data set and which the iris species variable equals Setosa. And what you'll see now is we've got Setosa data, 50 observations, 5 variables, which if I open, looks identical to the iris data set, but the species variable is only Setosa. And I am just going to very quickly copy and paste and do this for the three different ones. So versicolor, so which is versicolor, and virginica, which is virginica. What we have now, if I run these, is our 3 different data sets. We got versicolor, we have virginica. So now, instead, and this shows why the attach function is so important. Previously, when I was doing the quantiles of sepal length, it was from the iris dataset because that's what I had previously attached. So if I now want to use a specific one of these, let's say Setosa, the Setosa variable, I'll first attach Setosa data, and I can copy and paste this, I suppose, to get the tenths. Now it's going to be quantile of sepal length, but for the Setosa variable only. If I run that, you will see they are different because it's first of all, I attached the Setosa data file in the first place. So between this code, along this line of code, this would be likely sufficient for you to compute the descriptive statistics that you need using some variations of these, and it's also been, I suppose, useful to show making notes and attaching different data sets and extracting particular sections of a data set together. The next thing I'm going to do, and to conclude this video, is to show that we can visualize the data as well. So first of all, what I'm going to do is I'm going to visualize data using the tidyverse package, specifically ggplot, which is a package. So you'll see that ggplot is a package that is here, ggplot2. And it's a package used to create visualizations where GG stands for the grammar of graphics, but that's within the tidyverse. And the tidyverse also has sort of a language to it, but I won't go into that. I'm going to load the tidyverse package and then create a new section, visualizing data. And we're going to use ggplot to do this. So I'll clear this, and I'll start with a very brief overview of how ggplot works. So the first thing is its main function is ggplot. And if I run this, just this alone, what it does is it starts to create a plot for us. This has nothing in it, but you can see the plot has appeared. If I want to use the iris data, so I'll start by doing data equals iris, and I'll just run it now. Again, still nothing has happened, because all I told it is that it's going to be the iris data, but I haven't told it what's going to be done to it. The way that we start to do that is say, for example, what goes on the x and y axis, and we do that using aesthetic mappings. You can see when I've typed it there, x and y has appeared. So along the x axis, what I want is the different species. And you'll be able to of course change this depending on your own data. And what I want to plot, for example, will be sepal length. So this is going to be plotting from the iris data sepal length by species. If I run this line of code, what we get now is the beginnings of a plot. We have our species, we have sepal length, but we haven't told it how exactly we want what way we want to plot it. For example, is it going to be a dot plot? Is it going to be a box plot, and so on? And we do that by adding geoms. And if you start to type geom, you'll see the different plots that exist. So I'll start with a box plot. If I run this, you see I've added a plus button. I have dropped a line, but it's linking with plus. And now we have a box plot for each. We can see we have an outlier here, but we can also see our box plots. I might want to go a bit further, and I might want to use a different plot. For example, a violin plot. A violin plot used for density. You can see the different violins, or maybe I just wanted to show the data points themselves, and for this I like a jitter plot. Jitter gives a brief scatter, and it scatters them ever so slightly, so you still get an overview of your data with them spread a little bit. So we can see in terms of sepal length, setosa is generally smaller than versicolor than virginica. What's really nice about this is we can build up our plots. We can layer the different geoms. So for example, perhaps I want a violin plot, and on top of that I want to put the jitter plot, and don't forget the plus symbol. So you can see the violin plot was put in first, then the jitter plot, and it's really important to remember the order, because if I put the jitter plot first and then the violin plot, it goes in the order that you write them, so it overlaps in that way. And we can create really, really informative and information-rich plots by layering up particularly nicely. So for example, I can put the box plot next, and then the jitter plot, and we can start to see that it's going to turn into a very nice piece. What we can do is start to adjust them. So I'll start with the violin plot. So the first thing that I want to do is I'm going to give each species its own color. So I'm going to use aesthetic mappings. This is quite common. I'm going to fill it by species. So if I run this again now, it's going to give them different color, and it gives you the legend here as well. So it's starting to become more perhaps publication ready. That is quite strong, so maybe I want to make it a bit more transparent, and transparency is on a range from 0 to 1. You might need to play around with this. I'll try 0.25. So it'll go a little bit more transparent. I like that a bit more. Next we have our box plots, and I think the box plots are generally fine, but they're quite wide. So I'll change their width. So their width, we'll say, I'll try 0.1 for a moment. That might be too wide. No, that's fine. I could make them narrower or smaller. And the last thing is the jitter plot. So I'd like them to be the same colors as the violin plot. And I'll go, the difference, so you have so color is typically the outline, and fill is the fill. Because these are just a solid thing, it's going to be color that we use to change these. And this should give us dots that are the same color as our violin. I'd also like these to be a bit closer together. So a width of 0.1 would give them the same, or no, it wouldn't actually. I think they work differently depending on the geom. Yeah, so 0.1 is pretty close to the box plot, and then of course if we wanted those to be more transparent, alpha is the level of transparency, and I'll half their level of transparency. If I do 0, they would disappear completely, and you can see that, and it's starting to look nicer. And the last thing is we have a lot of different themes. And just use the classic theme, which will give us our X and Y axes. So there's a nice plot, which I could now export if I want to as an image file, a JPEG, or as a PDF. That's a pretty useful way to visualize descriptive statistics. It's quite an information-rich document. And here it is for sepal length. You may want to do that for all of them. So if I was to do, for example, sepal length plot, and that's what I'm going to call it. So just for now, I'm going to clear my console to tidy things up a little bit. I've just given it a name of sepal length plot, and I'll save all of this to my environment. So you can see now if I ever wanted to again, I could just type sepal length plot, and this will appear. It's very easy for me now to copy this, and I'll paste it 4 times. But each time I'm going to call it something else. So instead of sepal length, we're going to do sepal width here. So petal length and petal width. You can see it's really only the y-axis that needs to change. So here, instead of sepal length, I'm going to use sepal width. Here, instead of sepal length, it'll be petal length, and here will be petal width. If I run all of those, I'm going to get my plots, which will be saved up here, and it's now quite easy for me to paste their names if I ever want to call back to them. Down below, so I can run this, and this is going to give me what I already had, my sepal length, sepal width instead, and this is sepal width, petal length. You can see the difference in petal length now. It's much different than the others. And petal width. And of course the y-axes are changing as well. But and they can all be adjusted. You might want to make them slightly different. If you did want to export, so you can move left and right. If you wanted to export this one, you can click export, maybe as a PDF. You can choose the different sizes to export it as, and click save, and it will save. Or you can preview it in the first instance. But that then should help you to visualize your data, which is always really important, and visualize the distribution of it, as well as compute your descriptive statistics. And that's sort of it for this video.